This is the solution video of the puzzle that was called Squaring a Rectangle 2, and it was published on March 29th of 2024. And it was a puzzle provided by Mr. Matthew Arkers from Cambridge, and he kindly provided this puzzle to me. And it features a square containing a rectangle, a red rectangle, and also some line segments and two right angles over here. And the the problem is to prove that the red area is equal to AB times AC plus BE times CD. Let's put it over here as a reminder. Yeah, so we have to prove that red is AB times AC plus BE times CD. So that is the question. And I'm going to follow the route provided by Mr. Arkers himself using vectors and the dot product of vectors. And for that we define, let's say, first the vector A. If we put the origin at A, so at this point, then you can say that the vector A goes from the origin to the point D, and another vector, let's call it B, it goes from the origin to the point E. And what we know from that, if we take the dot product of those two vectors, A dot B, we know on the one hand that it is the projection of B on A times the length of A. So it is this length times this length, that's the dot product. But that is exactly because of the square we have also here the length AD. So that exactly equals the area, the red area. So we basically know that the red area is the same as the dot product of the vectors A and B. So that's one result. A dot B. But also now we can come to that same dot product by using an orthonormal basis, so using the Cartesian coordinates basically, and we choose it conveniently. We choose, of course, against the origin here, but we choose the orthonormal along this side and along that direction. We know those directions are at right angles. So if I draw a small square, let's say unit square, lying along, oh sorry, it was not quite good, like here, A to here, okay. Then this has, let's say we call it the base vector EX, so this defines the X direction. It has length 1, and along that one we have EY, so that's the Y direction of that coordinate system. But in that coordinate system, the point D, let's say the endpoint of the vector A, it has the coordinates AC and CD. That's very easy to see. AC is along that direction and along the X direction, and CD is along the Y direction. So we know, and let's put that over here, we know that the coordinates of A in that system are AC as X coordinate and CD as the Y coordinate. Well, similarly we can find the coordinates of B, and that's easy because it is the X coordinate is AB and the Y coordinate is BE, so the length BE. So those are the coordinates of the two vectors in the system along this orthonormal basis. But what we know from, if we take the dot product in that coordinate system, it is the same as multiplying the x coordinates and adding them to the multiplication of the y coordinates. So we know that a dot b is the product of the x coordinates, so ac times ab times ab plus the product of the y coordinates, so cd times be. But lo and behold, that is exactly the thing we are trying to prove. So we have found here that this is the dot product. Well, we already knew that a dot product is equal to the red area, so therefore we have proven the result which was wanted. So the red area is equal to AB times AC plus BE times CD, and that concludes the proof of this puzzle using the vector dot product.